All right, in problem 4 here, we're looking at a problem where we need to calculate Kc for the reaction. We're given information in order to calculate the initial concentration of N2O4, and we're given also the equilibrium concentration of N2O4. So it's going to require a little bit of extra work to figure out everything else. So this is where we're going to use the ICE table or RICE table, depending on which textbook you're talking about. So R for reaction, I is initial, C for change, and E then for equilibrium. N2O4 in equilibrium with 2NO2. Okay, so we're told that there's 0.625 moles in 5-liter vessel. 0.625 divided by 5 tells me my initial concentration of N2O4 is 0.125 molar. And that's all that was added in initially, so there's no concentration initially of NO2. All the NO2 that's going to be in there is going to come from the breakdown of the N2O4. Now we have to think kind of algebraically here. So every time we break down one of these, we lose one of those, and we gain 2 of these. So however many this is, we don't know yet, but every time we lose one, we gain 2 of these. And now finally at equilibrium, it's going to be 0.125 minus x. There was no initial here, so at equilibrium, there will just be 2x that's there. Okay, so let's write our Kc expression now. Kc is equal to N2 NO2 at equilibrium squared over concentration of N2O4 at equilibrium. And now we have an algebraic expression to put in for each of these. Up here on the top, it's 2x squared, and then there on the bottom, it's 0.125 minus x. Well, this kind of problem, which I call an easy ICE problem, is when we're given information about the concentration of any one of the species at equilibrium, because that'll allow us to solve for x. And so we're told that the concentration of N2O4 at equilibrium, so N2O4 at equilibrium is equal to, we've already said mathematically, 0.125 minus x. And that expression is equal to 0.0750. Well, now we can solve for x. So x equals 0.125 minus 0.0750. So x is equal to 0.05 molar. We'll still have to do just a tiny amount of work. So x is equal to that. So the concentration of NO2 is 2x. 2x is equal to 0.10 moles then. NO2 at equilibrium. Okay, so now almost ready to go. Kc is equal to 0.10 squared. I put in the 2x value. I still need to square it. And then 0.0750 was my given concentration at equilibrium for the N2O4. Okay, and so then my final concentration, final equilibrium constant here for this reaction is 1.3 times 10 to the minus 1, or just simply 0.13.